All right, so yesterday when we did the compound probability with the and the or and the contingency table and all of that, right? So the and the or, right? Even though we went through it and it took a little bit of time and all of that, that's not two separate questions. That's one question on the test, you know? And then so that's why it might seem like the test looked like it was more, but nah, it's not. Also, give you another example, the contingency table, right? Like that, we had mad steps there. Like there was mad questions there, right? We had the Democrat, the executive. Then we had the Democrat and the executive. Then we had the Democrat or the executive. Then we had the Democrat giving us the executive, all of that stuff, right? So that's mad letters, A, B, C, D, E, and all that. That's one question, you know? So yeah, like that's why it might seem like it was more, you know? Yeah. All right, give me 1 second. Appreciate it. I'm gonna reply soon. What I'm gonna do, I'm kind of having fun with you guys a little bit. Yeah. Right. So I'm like experimenting with different things, like I'm trying out AI and all of this. All right, so this what I want to do first, right? Let me give y'all these numbers right here, right? And I want y'all to give me the mean, give me the median, AN, right? And then I want you to give me the standard deviation, please. I'll give you guys a little bit of time. So let's start off with that. And while you're doing that, I'm just gonna get the next question ready. Nah, y'all should have seen yesterday. Yesterday was like next level up in here. Like next level. Yeah. Y'all know that tomorrow is President Carter's funeral and all that. Yeah. Oh, you don't know President Carter? Yeah. Carter. Yeah. Yeah, tomorrow's his funeral. Yeah. Yeah. Yeah, yeah. Yeah. It'll be on TV and YouTube and all that. How we doing out there? You guys are making progress with this? Okay, okay. All right. All right, that took a little while. So over here, trying out something new. So anyway, how are we doing? Did we finish this first one?
Yeah.
Got it. All right. What do we get for the mean?
154.2.
You agree? You agree?
Yes.
You got the same for the mean? What about the median?
208.
208. Okay, okay. All right. And then what about the standard deviation?
I got stuck.
That's stuck? All right, let's go through it. All right, no problem. Just want to reiterate that the mean is on the formula sheet, is written as the sum of x divided by n, which is add up all the numbers and then divided by the count of the numbers. And then the median, right? Remember, step one, put in order. Step two, choose middle number. All right. Let's talk about the standard deviation now. Okay. I'm going to cheat a little bit. So for our x's, we have 217, 208, 133, 37, and 226. All right. So what we want to do, right, is that we want to add up all of these numbers together, right? Which you all were able to do because you all found the mean, right? So the sum of x, right, this is going to be equal to the sum of all of these numbers. I heard 821. That's what I got. Perfect. Now in the second column, what I want to do, what's up, man? I want to raise this to the second power. So I want to square all of these individual numbers here. So did we get all the squares of these numbers? I got 47,000.
I did it differently. I actually wrote it out.
Okay.
I did, yeah, because I put X on the second column and then X minus.
All right. So we could do it that way if you want. We could do it that way if you want.
Like this, yeah.
And then like,
And
once
then
you get the answer, you put it as like the number on like the second power to everything.
Oh, once I get the answer for this, I do to the second, yeah, okay.
Yeah,
Cause then I seen the number that it was big, so I'm like, I'm
because
gonna be
what
doing
you,
something
what you
wrong.
did is when you got all the numbers, you subtracted it by the mean.
Right,
And then that's when you came with the answer.
yeah, that's what I
And
got.
then after that, that's when you do it to the second power.
This, I do to the second.
Yeah, that's what exactly what I think is.
All right.
So we got our mean, right? Mean is going to be this divided by 5. 164.2. All right, so I'm doing it out your way. All right. So our next column that we want to get a column that's x minus the mean. All right, that's going to be our next column, x minus the mean. So you're going to take each individual number, for example, 217, you're going to subtract the mean from it. And you're going to keep doing that straight down, right? Next one going to be like 208 minus the mean. You get the idea, right?
Right.
Yeah. So we're just gonna do that straight down. I'm gonna let me erase this real quick. I'm gonna do it on the computer and write it in. So this is gonna be x minus the mean. That's gonna be this number minus this number. Gotta edit that a little bit. Bob. Bob. All right. And I'm just gonna pull that down. And there we go, right? So when you did x minus the mean, you should have got, right, 52.8,
52.8.
43.8, negative 31.2,
Yes.
negative 127.2, and then 61.8. Perfect. And then now we got to do another column, right? In this column, you're going to square all these numbers, x minus the x bar squared, right? So now we want to square all those numbers, all right? So for me, let me see what I got. And immediately you're going to see why I don't like this method right now. All right. So I got 2,787.84. I got 1918.44. I got 973.44. I got 16,179.84. And I got 3,819.24. And we're on the same page with all that? Okay. So the next step after that is you want to sum, you want to add up all of the x means, the x minus mean squared, right? So this is just going to be, I'm just going to call this one sum of SQR. I'm going to call the sum of square, right? So this is going to be the sum of all of these numbers. Tell me what you get when you square, where you sum all of those numbers. Today's not too bad compared to yesterday. Like what weather-wise, I mean, in this room I'm talking, not outside. Yeah. Yeah, let me know if we're on the same page with this. Mhm. You don't got those numbers? You did it with the x and the x squared way? That's the way I like you to do it.
Yeah, 'cause
That's
I
good.
see you going with the X and X bar.
Yeah, I don't like this one. Let me see.
I was solving that, but then I
Good,
didn't know what to
so
do with the square and that 18.
so not quite. This is right the way you wrote this, but this is not right the way that this is written. It should look the same. All right. So this line shouldn't be underneath this. It should be only underneath this part. All right. And then
Oh,
that's
so I'm
fine.
not dividing the 5, I'm dividing it by the 18.
By the 821 square. You
Okay.
know.
But
Well,
this is right.
yeah, that looks right. Because we when I squared it before, you had all the same numbers as me, right?
Mhm.
Right. And I trust you know how to add, you know. So you just plug it into the formula and then that's it. Which calculator do you have?
I think I like this is something.
Oh, oh, you got that pink one? Oh shoot. Oh shoot. Yeah, so now we gotta type all that in. You know how to type that in your calculator? Oh snap. All right, go ahead. Try it out. Try it out. When I'm done with this question, we should have the same answer. All right. All right, what did you get?
It's gonna be a hard time with this calculator.
Right? That's what I'm telling you.
I know.
Yeah. Yeah. Not only that though, I don't like this process. You know?
Once I get this, I'll be
Yeah.
okay.
So look, when I add this up, this is what I got. 25,678.8. All right.
Yeah, I'm
So
by 2.
it happens. It's all right.
No,
Don't round. Don't round. Yeah.
that's what I thought I was rounded once I got
Nah. We don't round to the end. That's why I don't like this method. Right? We don't round to the end. All right. So now look, our variance s squared is gonna be the sum of x minus x bar, should have put that in parentheses, sorry about that, squared divided by n minus 1, right? So that's going to be the 25,678.8 divided by 5 minus 1. And then like, let's see what answer we get when we do that. So I got this divided by 4. So I come out with 6,419.7. Now you should have got that same answer right there. 6,419.7. We on the same page? You didn't solve that part yet? So you're that when you type in that formula that you got there, you should get the same number out.
Why is it not 6
No, because only 5 numbers. Yeah.
If it was 6 numbers, it would be 6
Right.
It depends on how many numbers there is.
Yeah. And how many are you gonna have on your final? How many numbers?
Wow.
Exactly. Okay. Yeah. All right. So after you do all of that now, to get your standard deviation, right, we have to square root our variance. So in this case, we're going to square root this number, the 6,419.7. So now when I square root that, let's see what I get. All right.
Yeah, 80.1.
80.1.
Yeah.
All right, that sounds good. Why you rounding it for me though? I like it all. 12303. All right. Yeah, I'm not a rounding fan. I like everything. Mhm. That's how I like it. I like everything. You know?
Yeah.
Good. Then we're on the same page. You're good to go. Yeah. So now you know what could change our answers to make it different, right? If you rounded up this number, the variance that you got before, the 6,419.7, that could change this 80.12303. You know, so always you don't want to round until the very end, right? If you want to round to 80.123, you could round that off. All right. I just don't like to round, right? If I was going to round, I like 4 decimal places. That's just my preference. I like four places after the decimal. All right. And that's that. Questions on this? We're good?
What do you say?
Any questions on this?
Oh, no.
All right, so that's the mean median mode. So we good on that. All right, try question 2 for me real quick.
And ain't that the one that we said with the yesterday?
Yeah. So you're gonna make a scatter diagram, right? I have to add in something real quick. So for part C, sorry, I got a little pop up. I want you to interpret your results. All right. So yeah, just do that for me real quick. Don't ignore that story. There's a story at the top. All right. Hi, how are you? Today feels better in here than yesterday. Yeah. Yeah. Oh yeah, outside is terrible. Yeah. So social work, you out to Lehman after BCC? That's good. I like Lehman.
Yeah. I graduated from high school.
Did you really? Wow, that's amazing. Man. Lehman High School. You know what I like about that school? Like they don't hold you back because of the regions. Like if you wanted to do an AP class, they let you. I like that. Mhm. I heard through the grapevine that in what year is it again? I forgot. It's 2025 now. Yeah. So I heard through the grapevine that in 2027 they getting rid of the regents in high school.
Yeah.
Right? Yeah. 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 You didn't take it?
I took the algebra one, but I didn't have to pass and graduate, and I took the English one.
Wow. What high school you went to? That's amazing. I don't know that one. Yeah.
Right to Taiwan.
Frederick Douglass. Got you. Got you.
Because I have my high school in Brooklyn, so
Got you.
like last.
Oh, they waived it during COVID. That's right. That's right. Yeah, yeah,
And then the one, the US history one, they
yeah.
did that Buffalo shooting put in the test, so they waived that one, we couldn't take it.
Right. Wow.
I feel like they should still get the test.
Yeah.
I suffer everywhere.
Everyone should.
Right. So so back in the day, right? I remember we used to have the Regents exam, and then when you came to CUNY, you had to do what's called a placement exam, right? Yeah.
Yeah.
So the placement exam though, it's how can I say this now? It was basic, but it didn't. If you failed it, let me not even say that. Everybody that took a placement exam failed it. Every single person. But it wasn't about whether or not you're gonna get into the CUNY. It's about where they're gonna place you. Yeah, yeah, yeah. That's how that was.
Yes.
So I mean, when,
What, they would put you in advance course?
If you did well on the placement exam. And if you didn't, then they put you back in remedial, right? So, oh my gosh. So I remember my friends, right? Like I had some friends like they're fluent in Spanish, right? You know, because they got abuela and all of that, right? But they would fail that on purpose to get placed in the remedial Spanish. Because remedial Spanish and like honor Spanish is the same credit.
Oh.
So it's like,
That makes sense.
yeah. So they would walk in and they'd be like, comer? That's how you say eat, really? I didn't know that. Wow. Oh man. But I remember when I was coming in though, right? Like I wasn't claiming no language or nothing. I had to take the math placement exam because they let me slide with the English because of the regions, right? So when I took that math placement exam, oh my gosh. This is high school. It's next to City College. Oh my gosh, I can't remember the name of it right now.
not random.
Randolph, that's it, right? So I went into that high school, right? And like that's where the exam was gonna be. At the time, I don't remember if Randolph was in the high school. Like they, I don't know. For some reason we took our test there. It went into the school. This was like the longest corridor you ever see, right? So I go down there. The room to take the exam is all the way at the end of the corridor. Okay. I get there mad early, right? Because I'm young, right? Back in the day, I didn't know how to take buses. I only knew trains, right? So so like I had to take, and I live like on the other side of the Bronx. So like where the six line is. So I took the six all the way down to like 14 or 42nd, I forget which one, and like transferred over to get like the one or the three train to go up to City College. I'm young. And then on top of that, it's a morning exam. So I had to leave really, really early when there was no express trains. So I'm crazy tired, right? When I left my house, it was pitch black. When I got off the train at City College, like you know when the sun is just starting to rise and the sky is like blue, that's what happened, right? I go into to go take the test, right? Okay. This room, there was watches allowed, no cell phones, none of that, right? We just had to sit there in front of a computer and take this exam. But we got pencil and paper, right? No calculators either, it's terrible, right? So we're doing the exam, right? Oh, another thing too, when I after I show up, right? Mad high school students show up. Like this corridor was packed, mad people. Yo, yeah, it was crazy. It's crazy.
So you can, like, you have a region view, so like you don't have classes.
No, this particular test. It was done. I don't remember if it was done on a Saturday or something, but there was no school when we were doing that. Yeah, yeah, yeah. We had Region Week, but this particular placement exam wasn't inside of Region Week. It was like after or something. Yeah. So I remember I go in there to take the test now, right? And there's mad people, so it takes a while for everybody to get seated, right? This room had no windows, right? Like we couldn't use our phone, so phone wasn't near me, no watch, none of that, right? So I just sit there and I'm just doing the test, right? And it's just a math test. We're just doing the math test, doing the math test. All I hear chairs moving, right? And people getting up and leaving. That's it, right? Just getting up and leaving, right? But I'm just doing my test, right? I'm just doing my test. And in the back of my mind, I'm just thinking like, yo, college is this hard? Like, how y'all finish before me? Like, and like I know I'm okay in math, but like I'm not this bad in math. Like, how y'all finish before me? Like, and I'm still going, right? So I'm still doing this test. I'm still doing the test. And then it gets to the point where there's only two people left, me and another gentleman. Everybody's gone. And I'm like, yo, I'm not even going to college. Like, I'm gonna give up. Because like how they finish before me? It's crazy. So long story short, what ended up happening, right? When you take the placement exam, everybody fails it, right? But it's when do you fail it, right? The reason why I took so long is because I kept passing, right? So everybody else, they were failing earlier, so they were getting placed in remedial courses, you know? So like for me, I didn't fail until calculus two. So that's why like I just kept going and all that. Yeah, but it was nice though. Like I like the placement exam and the remedials because they didn't expect you to know anything coming into school, Everything was just will build you up, you know. Nowadays, it's like, yo, sink or swim. Here's your class. Like, um, it was fair. Yeah. Yeah, it was definitely fair. I'm not gonna bash it or anything like that. But now what they do, they look at your grade in school and your region's grade. And based off of that, that's how they place you into which class you're gonna be in up in college now. But now when you have no more regions and you're just going off the school's grade, you know, like you can't tell me that a C plus in Bronx Science is the same C plus in Christopher Columbus. That's not the same C plus, you know? But huh? Yeah.
Right?
Are you reading and writing levels are really low? Terrible. Can't from a regular, like, sentence.
I'm not gonna lie, if it wasn't for Google Translate and spell check. Oh man, and Grammarly? Oh, that's my best friend. I love me some Grammarly. You know what? I'm gonna sit and pay for it. That's how bad it is. Like I'm on the fence. Like I'm about to, everybody here though, y'all all should be using Microsoft Copilot. All right. It's an AI. Just like Grammarly and Gemini and all of that and ChatGPT and all this stuff, right? But the thing is that as CUNY students, we get Microsoft Office for free, all of us, like through our email, right? So we have like the pay version of Microsoft Copilot for free. So we should be killing Copilot, putting everything up in there, you know? Had a girl in my class last semester, right? Um, failed math 23 a couple of times, right? She came in and it's like I would like teach the class, give them homework and all that, and she would actually take the questions, throw them into Copilot, and say like, "All right, give me a question just like this." Boom, and then that's how she practiced. End up getting an A in the end of the class. You know, from F to A. Yeah. All right. Finish this real quick, and we'll go over it in a second. Remember, I'm looking for three things here, right? I want the diagram drawn, right? I want you to tell me if it's positive, zero, or negative, and I want you to interpret the results. All right. So let's try and do this real quick. So I'm going to start by drawing the diagram, like so. Of course, this is my X and this is my Y. Just going up to the story real quick. X is hours studied. I'm just going to say hours. Y is score. You notice how I'm labeling my diagram? You guys label your diagrams as well. Don't just simply say X and Y. All right. Next, we look at our numbers. So I'm looking at the X. X, I noticed the biggest number there in the X is 10. So I want to go from 0 to 10.
Oh,
Yeah. So I was going to ask you how you want to go to from 0 to 10. You want to go by ones? You want to go by twos? By ones? Yeah.
You can start with two.
Yeah. All right, let's do that. So over here, this is 0. So I'm gonna call this 2, 4, 6, 8, and 10. All right, now let's look at the Y's. For the Y's, I want to go up to 90 and 60 and 60. You could.
I started with 65 all the way to 95. So I started with 65, 70, 75.
Let me think.
Right?
I can.
65, 70.
I'm gonna do it that way. Yeah. But watch what I'm gonna do here. I make this little symbol here indicating that I'm gonna skip a whole bunch of numbers, right? And I'm gonna start off with 60, 70, 80, 90, 100. That's legal. You can do that. All right. And then we just make our points, right? Now you guys remember I'm a fan of the X's. So I'm gonna be doing X's, but if you guys did dots, dots are fine. Dots work. So my first pair, go ahead. Yeah. So my first pair is gonna be 2 and 65, right? So I'm gonna come across the 2. I'm gonna go up to 65. I think it's somewhere like right here. You don't have to be like precise, just do your best. Just do your best. My next number is 4 and 75. So I'm gonna come across the 4, go up to 75, which I think is somewhere like here. My next number is 6 and 85. So I'm gonna go across the 6 and then go up to 85, which I think is like here. My next number is 8 and 90. 8 and 90, which I think is like here. And then my last number is 10 and 70. So this is 10 and 70, which is like here. Okay. So that's my diagram. This is what I'm looking for. That's part A. All right. Questions on this? Awesome. All right. So now I wanna jump to B real quick.
I got the coefficient for that. I don't know.
The correlation coefficient?
Yeah.
That's cool. I don't really need it, but go ahead if you want to tell me it. What is it?
7.39.
All right. Is it positive or negative?
Positive.
Right.
Positive.
So that's my question for B, right? Would you say that this correlation coefficient is positive or negative? So we're gonna say positive.
Well, the fact I don't write the correlation, I just have to
Nope.
write the positive.
Just tell me positive or negative. That's all I want. You probably did in the calculator. You don't want to see it. You don't want to see that formula.
That's, is that. So would it be Y is increasing Y?
X is.
Think of it more like this, right? Where's majority of the points going?
Okay.
Right? That's how you look at it. Yeah. So like majority of the points appear to be doing like something like that. So that's why we say positive correlation. As long as you don't tell me zero, right? Zero is a theoretical situation that only occurs in your textbook. It does not occur in real life, right? It's either positive or it's negative. It might be a strong positive or like a weak negative, right? But it's going to be one or the other. It's not going to be true zero. True zero doesn't exist. All right. So cool. So now you told me B, right? Here's the hard part. C. I want you to interpret this, right?
That increases, I think you said yesterday, something.
So give me the sentence as
Has X, advanced by.
and remember X is our hours, right? Increases. Y, which is what again? Your score. X is not ours? My fault.
Yeah, X is ours.
My fault.
No?
Oh, X is not, no.
Yeah. I got you. All right. So why the score is doing what? Increases. Okay. Increases. So whenever the correlation, right, is positive, as X is increasing, Y is increasing. But if the correlation is negative, then as X is increasing, Y is decreasing. All right. All right, we did good on that. All right. Any questions on this, or are we good to go so far? Good? All right. You still copying, or are you good? Good. All right. All right, do this for me real quick. A and B. And then we'll look at something new today.
Oh, so that's the new one?
This is what we did yesterday. Maybe I'll.
Oh, I know this one, all right.
Thought of that, but that's a good idea to take a picture and we can zoom in.
Yeah. Fine.
Now, the second grade, there was like, oh, you know, we're laughing, that's fine. Like that. I'm used to it now. I don't need to read, I need to see far, I like to see the board and stuff.
Really, that's how I started, but then, I just don't really,
You need both.
yeah.
Oh, man. I mean, you got contacts. I'm a wimp though, I can't touch my eye. Yeah. Like I drop eye drops in my eye and I don't know how I do that. The eye surgery?
Yeah.
Scared. I'm just scared of everything. But I got used to the glasses though. You know, so it's a part of me, you know.
That's a part of it too.
Yeah. Every morning gotta clean them. You know. You know what I hate though? Like, you know, this is how like say you get tired, and you know, like when you get tired, like your eyes will get like kind of um glossy or like lubricated, whatever, right? And then like maybe you start blinking, right? So with me, it's like when I blink, it's like the lash carries the moisture and just flicks it on the glass. So then now and it's not like it's water, like this is like some salt type thing or whatever. So it stays when it crystallizes in the morning. So I have to clean my glass every morning.
But your glasses, they scratches.
Oh my God, I have so much in my glasses. So, so first off, like if I was to like put the camera on and like show you guys my face like in the video, it would look like I'm doing something crazy on the computer when I'm not, right? Because it has a blue light glare reflection. Yeah, so it has that. It has the nighttime yellow reflection. So like like when you're driving and then you see like people got their high beams coming at you. So my glasses reflect it right back at them, you know? And then what else? I walk outside in the sun, they turn into shades. Yeah. Mad. So yeah. They have like the anti-fog thing too. I'm not saying they don't fog when I'm coming into a warm situation, but like it's not terrible. Yeah. Huh? What happened?
No, so you see that that's
Yeah,
good.
yeah, yeah. Yeah. Only bad thing is I only got like one pair. I have a friend, she goes online, different websites, right? And they sell glasses like real cheap, the frames and stuff. So she buys like all types of like cheap frames, right? And she just sends them her prescription and she gets her prescription lens in those frames. So like her glasses all match her outfits. Yeah. Mm. Mm. Go ahead.
B is kind of confusing.
Figure it out.
It's kind of confusing. I understand the guys and using it, they should, but it's kind of confusing because you look
But which one you got to multiply?
yeah, exactly. 25% use credit card, of those 25% who use credit card, 7% spent over $100.
Right?
And
All right. I'm gonna give y'all like 5 more minutes real quick.
also about
It's all right. You get another chance though, man. SU would never give you another chance.
yeah.
It's a wrap at that point. Let's look at the first one. So a survey of 100 students revealed the following information about their extracurricular activities. 40 students are in the math club, 30 students are in the science club, and 10 students are in both clubs. What is the probability that a randomly selected student is in either the math club or the science club? All right. So remember our formula here, right? This is going to be the addition one, right? So the probability of math or science is going to be equal to the probability of math plus the probability of science minus the probability of both of them.
And you can plug the numbers together in each category,
And that's it.
and so you get it.
Yeah. Did I lose anybody with the formula or are we good? Good? You good with the formula? I'm just copying from chapter 5. Chapter 5 and the formula sheet got this. All right? Yeah. After this, just plug it in. Forgot what math is. 40. So we got 40 over the 100 plus the science, which is what, 30 over 100 minus the both, which is what, 10 over 100. After that, a little bit of math. Bop, bop, bop. I heard 60. That's good. I would accept this, but if you want to give me 0.6, I'll take that as well.
Oh,
Well, and that's it.
the second one.
Yeah. All right, we're gonna check it. We're gonna check it. But for the first one though, any questions on this? Are we good? All right, so whenever we see or, it'll be an addition rule. All right. All right, let's look at this. So a store, this is part B. A store has 300 customers. 40% of customers purchase a product. Of those who purchase a product, 25% use a credit card. Of those who use a credit card, 10% spend over $100. What is the probability that a randomly selected customer purchases a product, uses a credit card, and spends over $100? Oh, shoot, this is a hard one right here. This is a hard one right here. In fact, I think it's too hard.
See what I mean? Because
Yeah.
I put all the numbers together, they said that there was another.
There is a way to do this, but I don't want to show it to y'all because it's not on your test.
Okay.
But I will change the question. 1 second.
Wait,
You want to see it? I got you on Thursday, right? Write it down, and then not this Thursday, next Thursday. All right. After your final, I'll show you. And let this be a lesson, right? This is why when you guys use AI, y'all can't ask it to write y'all papers, because stuff like this happens. Tell you the truth, I didn't really read the question, I just copied it. But this is better. So a survey of 200 people found that 60% own a smartphone. Of those who own a smartphone, 75% use social media. What is the probability that a randomly selected person from the survey both owns a smartphone and uses social media? What are you multiplying? What?
Okay. Wow. Going back to that question.
Yeah.
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 The correct answer, it was 0.1.
Good. That's good. I'll walk you through it next week though.
Yeah, I use multiplication.
It is. You have to use it multiple times though to get it. Yeah. But it's something that's beyond the scope of what you learned in this class. But if you are interested, I got you next week, Thursday. Yeah. Exactly. All right. So just to recap, right? They want to know what's the probability of smartphone, social media. I'm gonna say phone and social media, right? And then we have to look at what we're given, right? So we're given the probability of phone. That's 60%. And we're given the probability of social media given that you use the phone, which is 75%. All you got to do is just plug it in, right? So this is going to become probability of social media given that you use the phone times the probability of the phone, which is going to be equal to 60% times 75%. And what's the answer? 4875?
Oh, 0.45.
45? Hmm.
You should get that.
Yes.
0.45.
Okay. And did you use the percent that we talked about yesterday? Awesome.
On the calculator.
Yes. Good, 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 good. What about,
Did you get 0.45?
That's last. That line.
so that's given, right? So that's social media given that you have the smartphone. Right? So it's not dividing, it's labeling.
When I do this on paper, do I convert the parentheses to decimal or leave it as a?
For that calculator, yes, you're gonna convert that to decimal. So you should say 0.6 times 0.75. I highly recommend though, getting the other calculator. It's TI 36X12. It's the one that everybody else has. Highly recommend getting it. You will see why, sure. Any questions on this? Anybody? What? You didn't get this answer? 0.45? What was the question? I'm sorry.
Oh, no, let's talk about the calculator. Let's talk about it.
That one's a bomb. You just see me up in the supermarket with this calculator, like, yo, like, I know this is not a good deal, right? Mhm. Right. I'll be doing that. No, but so my issue is like they'll have two different sizes of something. Like say I'm buying toilet paper, right? So they got like the 36 bundle, they got the 20 bundle, and then they got the little individual ones. So I'm like, which one is the better price? You know, so I'm really there with the calculator, like click, click, like who's giving me the most bang for my buck? You know? Because like, even though the obviously the 36 bundle is going to be more money than the individual ones, right? But like if you were to take up 36 of the individual ones, that's more money than the 136 bundle. You know, so like little things like that. So I try to figure out who has the better value. So that's how I shop. I shop on value. You know? All right, we're gonna jump into something new today. Excuse me. As soon as I get to the right page, 1 second. So the topic that we're going to go over today is going to be an introduction to random variables and probability distributions. All right. But there's something very specific I want to go over with this. Just bear with me 1 second. Let me start off with a little definition for you guys real quick, all right? Just something I want you guys to know, and then I'm going to highlight what we're going to be doing with this, all right? So a quantitative variable, X, right? Quantitative is a $500 word for number, right? A quantitative variable X is a random variable if the value that X takes on in a given experimental observation is a chance or random outcome. A discrete random variable can take on only a finite number of values or a countable number of values. A continuous random variable can take on any of the countless number of values in a lined interval. All right. So for our test, right, we're actually going to be doing continuous random variables. All right. Just wanted you guys to know that. And of course, all the usual rules of probability still apply. Remember, like all probabilities between 0 and 1, etc. We need to chill out, yo. Like, 'cause we was good a second ago. So, what this is going to lead to is our binomial experiments, right? Or our binomial distributions, right? Which is a question on the test. All right. So let's talk about it real quick. Again, in case you guys blank out on the test, so I feel like if you guys have the understanding of it, it might help you just in case. All right. So binomial experiment. On a TV game show, right, each contestant has a try at the Wheel of Fortune. The Wheel of Fortune is a roulette wheel with 36 slots, one of which is gold. If the ball lands on the gold slot, the contestant wins $50,000, right? No other slot pays. What is the probability that the game show will have to pay a fortune to three contestants out of 100, right? So in this problem, the contestant and the game show sponsors are concerned about only two outcomes for the Wheel of Fortune. The ball lands on the gold or the ball does not land on the gold. This problem is typical of an entire class of problems that, let's continue, are characterized, right, by the features that there are exactly two possible outcomes for each trial of interest, right? These problems are called binomial experiments or Bernoulli experiments. Now we're getting kind of fancy, right? After the Swiss mathematician Jacob Bernoulli, blah blah blah. We're getting kind of fancy there. But here's what you need to know. These are the features of a binomial experiment. So there is a fixed number of trials, right? And we denote this number by the letter n, right? So we will have a sample size n, right? Whenever we're doing the binomial experiment. The n trials are independent and repeated under identical conditions, right? Each trial has two outcomes: success, denoted by S, and failure, denoted by F, right? For each individual trial, the probability of success is the same. So we denote the probability of success by P and that of failure by Q, right? Remember this? So since each trial results in either success or failure, right? The probability of success plus the probability of failure is equal to 1, and the probability of failure, Q, is equal to 1 minus the probability of success, P, right? The central problem of a binomial experiment is to find the probability of R successes out of n trials, right? By the way, if you're wondering, this is all on your formula sheet. This is in chapter 6 right here. Right underneath binomial distributions. That's where we are right now. I'm just trying to elaborate so that you guys understand what you're looking at when you get to the question, right? So let's look at an example. So let's see how the Wheel of Fortune problem meets the criteria of a binomial experiment. We'll take the criteria one at a time, right? So one piece at a time. So here's our solution, right? So each of the 100 contestants has a trial at the wheel. So there are n equals 100 trials in this problem, right? Because you have 100 contestants, right? Assuming that the wheel is fair, right? You know that doesn't happen often in real life. The trials are independent, right? Since the result of one spin on the wheel has no effect on the results of the other spins, right? So if I spin the wheel, I have my chance of winning. You spin the wheel, you have your chance of winning, right? My spin doesn't affect your spin, like if I go before you and vice versa, right? That's what that means, right? We are interested in only two outcomes on each spin of the wheel. The ball either lands on gold or does not. So let's call landing on gold success, right? And not landing on gold failure, right? In general, the assignment of the terms success and failure to outcome does not imply good or bad results. These terms are assigned simply for the user's convenience, all right? Just laying the groundwork. All right, so on each trial, the probability P of success landing on the goal is 1 out of 36. So there's 36 slots in the Wheel of Fortune, and one of them are gold where we'll win money. All right. So since there are 36 slots, only one of them is gold, blah, blah, blah. Consequently, the probability of failure, Q, right, is 1 minus the probability of success, or 1 minus 1 over 36, which is 35 over 36. All right. We want to know the probability of 3 successes out of 100 trials. So R, which is our number of successes, right, is going to be equal to 3, right? And don't worry if you're trying to remember all this, it's right here. First line. R is equal to number of successes, P is the probability of success, Q is equal to 1 minus P. Y'all don't got to memorize it, it's right there. All right. Anyway, it turns out that the probability the quiz show we'll have to pay the fortune to 3 contestants out of 100 is about 0.23. And then later we're going to see how this probability is computed, right? That's what we're trying to get to. So now we're about to take it up a notch, right? Yikes. So now we're going to be computing probabilities for a binomial experiment using the binomial distribution formula, all right? Or for those with the calculator, we're going to use that. The central problem of a binomial experiment is finding the probability of R successes out of N trials. Now, we'll see how to find these probabilities. Suppose you are taking a timed final exam. You have 3 multiple choice questions left to do. Each question has 4 suggested answers, and only one of the answers is correct. You have only 5 seconds left to do these 3 questions. So you decide to mark answers on the answer sheet without even reading the questions. Assuming that your answers are randomly selected, what is the probability that you get 0, 1, 2, or all 3 of the questions correct? All right? 0, 1, 2, or all 3 of the questions correct. So we're going to talk about this. First, I want to build it up so that you can appreciate the formula a little bit. So this is a binomial experiment. Each question can be thought of as a trial. So there are n equal to 3 trials. The possible outcomes of each trial are success S, indicating a correct response, or failure F, meaning the wrong answer. So the trials are independent. The outcomes of any one trial does not affect the outcomes of the other. What is the probability of success on any one question, right? Since you're guessing and there are 4 answers from which to select, the probability of a correct answer is 0.25, right? The probability of Q, a wrong answer, is 0.75. In short, we have a binomial experiment with n equals 3. Our probability of success is 0.25, and our probability of failure is 0.75. Now, what are the possible outcomes in terms of success or failure for these 3 trials? Let's use the notation SSF to mean success on the first question, success on the second question, and failure on the third question, for example, right? There are 8 possible combinations of SS and F, right? There are SSS, SSF, SFS, FSS, SFF, FSF, FFS, and FFF. All right. So there we go. This is what's called a sample space. No, you're not asked to do that on your test. I'm just trying to build some understanding real quick. All right. So to compute the probability of each outcome, we can use the multiplication law because the trials are independent, right? For instance, the probability of success on the first 2 questions and failure on the last is the probability of SSF, which is going to be the probability of success times the probability of success times the probability of failure, right? Which is going to be P times Q, or P squared times Q, which is 0.25 squared times 0.75, which is 0.047. In a similar fashion, we can compute the probability of each of the 8 outcomes, right? And then these are shown in the table, and you're going to see that. All right. So I'm going to show you this table. This table is massive. Here you go. So we have our outcomes here. This is success on all 3 questions, right? And then this is how we're computing it, probability of success to the 3rd power, which is 0.016, so on and so forth, right? So this is the likelihood that we get all 3 questions that we're guessing right. This is the likelihood that we only get 2 of the questions right. This is the likelihood that we get 1 of the questions right, and this is the likelihood that we get none of the questions by guessing. Right? Okay. Just to elaborate on this, I want to elaborate on the 1 for a little bit. You notice how there's 3 different scenarios for 1, right? Okay. So now we can compute the probability of R successes out of 3 trials for R equals 0, 1, 2, or 3. Let's compute the probability for 1. The notation probability of 1 stands for the probability of 1 success. So that means I get 1 question right and 2 wrong, right? But there's 3 ways that I could do that, right? So for 3 trials, there are 3 different outcomes that show exactly 1 success. There's the outcome where, let's say you get the first question right and the next 2 wrong. Or let's say you get the first question wrong, the second question right, and then the last question wrong. Or let's say you get the first 2 questions wrong, and then you get the last question right, right? So since the outcomes are mutually exclusive, right, we can add the probabilities together. All right. So that's what we do. Right. So we have the probability of getting the first question right, plus the probability of getting the second question right, plus the probability of getting the last question right. Right. Long story short, add them together, you get 0.422. That's it. All right. Or if you were up here, you're just adding these 3 probabilities together. That's all it is. All right. And then also, in the same way, we could find the probability of 0, 2, and 3. And then these values are going to be shown in the table. So the probability of no questions right, 0.422. The probability of getting 1 question right, 0.422. The probability of getting 2 questions right, 0.141. And the probability of getting all 3 questions right from guessing, 0.016. All right. So it's possible that you could get all 3 questions right, but it's not probable. Right? Mhm. So we have done quite a bit of work to determine your chance of R equals 0, 1, 2, or 3 successes on 3 multiple choice questions. If you are just guessing, now we see that there is only a small chance, about 0.016, that you will get all of those questions correct. All right. So this table can be used as a model for computing the probability of R successes out of only 3 trials. How can we compute the probability of, say, 7 successes out of 10 trials, right? We can develop a table for n equals 10, but this would be a tremendous task. I mean, you've seen how 3 was, right? Right? Imagine we doing it for 10, right? I gotta scroll up and down now. You know, it's like it's so much work, right? But this would be a tremendous task because there are 1,024 possible combinations of success and failure on 10 trials. Yikes, right? Fortunately, mathematicians have given us a direct formula to compute the probability of our successes on for any number of trials, right? That's what we get into right now. So basically, all this work that you saw that was done, we don't got to do that for our final, basically. Hold on one second. Let's talk about how we're gonna go about these questions now. So I want to compute the probability of R using the binomial distribution formula. So privacy is a concern for many users of the internet. One survey showed that 59% of internet users are somewhat concerned about the confidentiality of their email. Based on this information, what is the probability that for a random sample of 10 internet users, 6 are concerned about their privacy, the privacy of their email? All right. Now, I don't want to build no table with all of that. All right. So we're going to talk about how to do this. I'm going to show you guys a few ways. So let's just note something, right? This is a binomial experiment. You're either concerned about the your privacy or not. All right. There's going to be 10 trials, right? If we assign success to an internet user being concerned about their privacy of emails, the probability of success is 59%. So we're interested in the probability of 6 successes. So we have n is equal to 10. Our probability of success is 0.59. Our probability of failure, which remember is going to be 1 minus 0.59, is 0.41. And our number of successes that we're interested in is R is equal to 6. All right, all right, all right. So now we got a couple of ways we're gonna do this, right? First way, I'm gonna go old school, then I'm gonna come modern, right? We'll use the formula sheet, right? Using the formula sheet. So with your formula sheet, you're going to turn to the binomial distribution table, the first one right here. In this question that we have, our n is what? 10, right? So your n is in this column right here. You're going to go to where n is 10. So we're going to have to turn the page. And we're going to have to find where the 10 is, right? Found it. Now that we have the 10, right, which is this bottom portion right here, right? Our probability of success was what? 0.59. Crap, that's not even on here. Let's just say it was 0.56. I mean 0.60. I'm sorry, right? Just come here, and you would just come down to the number where you're looking for, and then go down to the 6, and that's where that answer is. I don't like this process, but this is one way that you can do it using the table. All right. I'd rather you guys use the calculator. All right. So let's talk about the calculator now. All right. Bear with me 1 second. I just got to get the calculator. Okay, here we go. All right. So we got n equals 10, probability of success 0.59, and r is equal to 6. Just going to highlight those real quick. All right, that's all we're going to need. We want to know, what is the probability of 6? All right. So in your calculator, you're going to press, hold on, I got to get my pink out. All right. You're going to press second, and then you're going to go to distribution. All right. Second distribution. All right. When you're in distribution, let me write that. Second, and then distribution. When you're in distribution, right, I want you to go down. And this is the down button right here, in case you're wondering, right? I want you to go down to where you see binomial, PDF. And binomial PDF, right, is the same thing as the probability of R equals to something, right? So whenever they ask you a question, what's the probability of R equals to 8? Making it up. Binomial PDF. Go ahead. What's your question?
I don't see it.
You don't see it? Did you go across the distribution? All right. So you go second distribution, and my fault. You should go across the distribution. I should have said that. You go across the distribution and then go down to binomial PDF, right? Now, the first thing that they ask in binomial PDF is what? The trials, right? Am I correct about that? All right. So trials is the same thing as your N, which in this case is what? 10, right? Probability of success is the same thing as your P, which is the 0.59. And your number of successes, which in this case is X, right, is the same thing as your R, which is 6. After you enter in all those numbers, click enter. Give me the answer. What's the answer?
0.2503.
Say it again, 0.25. Perfect. And that's it.
So we can use this one.
Yes. Because what's the alternative to not using it? The table. How can you prove that you didn't look it up on the table? All right. And this is nothing. Wait till you see tomorrow. TI 36X Pro. $20 at Staples. Do not pay $20. Go online and find it for cheaper and price match it. All right. Questions on this? Make sense? All right. This is the way I want y'all to do it. In terms of showing work, for me, this is showing work right here. You identifying for me, what is the trial? What is the probability of success? What is the number of successes? I want to see that written out. All right.
It's the,
Mm-hmm.
or we're not doing failures.
I don't need failure. The calculator calculates the failure for me and all that. Yeah. If you're wondering how the calculator gets this answer, looking back at the formula sheet, you see where it says binomial probability distribution, the probability of R is equal to N choose R times the probability of success raised to R times Q raised to the N minus R power in the front. This big formula right here, that's what the calculator is doing for you. That's how the calculator gets this answer. Okay. So that's that. Let's move on. There's more to this topic than just this. Now we're about to flip the script. So now, using a binomial distribution table, in many ways, we will be interested in the probability of a range of successes. In such cases, we need to use the addition rule for mutually exclusive events. For instance, for n equals 6 and the probability of success equal to 0.5, what is the probability of 4 or fewer successes? Essentially, I'm asking you, what is the probability of R less than or equal to 4, right? And we know which numbers are less than or equal to 4, right? They are what? 4, 3, 2, 1, and 0, right? So I want the answer for the sum of all of these numbers. Now I just showed you guys how to calculate for 1, right? If I ask you what the probability of 4 is, you guys know how to do that, binomial PDF, right? Now, when you guys were looking in the calculator, you probably saw that there was another functionality in there called binomial CDF. This is CDF, right? It does the sum for you as well. All right. But let's take it back. Let's go old school real quick. Let's go with the formula sheet for a second, and then we're gonna build it back to the calculator. All right. So on the formula sheet, again, I'm going to the binomial distribution table. Right? Just giving you guys options. Our n in this question is 6. So I gotta find n equals 6. So come down to where n equals 6 is. Everybody's there? All right. So now that we're at n equals 6, our probability of success, our p-value, is 0.5. So look at the very top. Let's find out where is 0.5. Everybody see 0.5 at the top? It should say 0.50, right? You come down to where the 6 is, right? They want to know what's the probability of R less than or equal to 4. So I want 4, 3, 2, 1, 0. So all you have to do from the 50 coming down is just add up all the numbers in that line for 0, 1, 2, 3, and 4, right? Which is the first 4 numbers, 0.16, 0.094, 0.234, 0.312. You just add those numbers up, and that's the answer to this question right here. All right? Or we use a calculator. All right? So let's talk about how to do this one on the calculator. Okay, right here. I just want to recap real quick. We're trying to find out the probability of R less than or equal to 4, which is the probability of 4 plus the probability of 3 plus all the way up to the probability of 0. All right? Just to recap that. and we're going to do this in the calculator. It's going to be the same kind of process, right? So we're going to hit second and then distribution. So second, then we're going to go to distribution. Then you're going to go across. Then you're going to go down. And you want to go down until where you see binomial CDF. And the binomial CDF is the same thing as the probability of R less than or equal to some number. All right? Binomial CDF is the probability of R less than or equal to some number. All right? They're going to ask you the same thing. What's my trials? Trials is the same thing as your N. What was my N in the story? 6. They're going to ask you, what's your probability of success? And success is going to be what? It's going to be the same as your P, which in this case was 0.50. Then they're going to ask you, what's your number of successes, X, or that's going to be the same thing as your R. In this case, this is going to be 4. And then you just hit enter. What's the answer that you guys got? That's it? You got that too? Not bad, right?
Same thing for going to the table, just adding up.
Adding up the first 4 numbers, you should get the same answer doing that. So you go to n equals 6, go across to the probability of success, which is 0.5, go down to where the first 4 numbers are in that column. You're going to add up the 0, the 1, the 2, the 3, the 4, and you should get the same answer. Maybe it's off by like the last digit, but it should be the same answer. Like maybe you get 0.891 when you do it, but it should be the same. So this is how you do less than or equal to, right? Let me ask y'all something. Let's just think outside the box for a second. If this wasn't R less than or equal to 4, say it was R greater than 3, what would I do? How can I get R greater than 3? What do you think? And no, the calculator can't do that. So give me some ideas. How can we manipulate the calculator to give you that answer? What do you think? Not that hurts.
The number of child.
Same number of jobs, that doesn't change. What could I do? The question was, what's the probability of R greater than 3, right? Write this up over here. Let's say it was the probability of R greater than 3, right? The calculator can't do greater than, but what can the calculator do? It could do less than or equals, right? So I can't do probability of 3 plus probability of 4 plus all the way to probability of 6. I can't get that. But I could get what? I could get the numbers smaller than that. I can get 2, 1, 0. So if I get the probability of 2, 1, 0, what can I do to get this answer? I can find the, starts with a C. We didn't talk about it in this class, but you guys might have talked about it in your class. You can find the. Well, that's my reason. Say it again. Coefficient. Coefficient, close. Coefficient starts with C also. That's everything. I hate that guy. On your formula sheet in chapter 1. Or chapter 5. Chapter 5.
The combination,
A combination at the very top.
the combination.
Complement. Define a complement, right? So I can't find 3, 4, 5, 6. But what can I do? I can do 1 minus the probability of 2 plus the probability of 1 plus the probability of 0. Remember, one of the rules of probability, all probabilities must add up to 1. Right? So if I take 1 minus what the calculator can do, that's giving me this answer here. So if it was greater than, that's how you would do it in the calculator. All right? And we'll go over that. It's just about manipulating everything.
The question was if it was greater than 3.
If-
Our answer was greater than 3.
Right. Oh wait, did I make a mistake? I'm sure I did. The 3 should have been in there. Let's go catch. 3 is not bigger than 3. 4 is bigger than 3. So 3 should have been in here. Right? We'll just add it in right here again. Let's get catch.
So which is. What the rest of the question like that? Are there any specific-
Yes. This is not so. But you can do it. I promise you it's not that hard. Let me show y'all the table real quick in case you guys want to verify this answer that we had above. All right. So we got our probability of success is 0.5, right? And the 6, right? And then you have the 0, the 1, the 2, the 3, the 4. You just add these up, you should get the same answer that we got up here. So that's if you don't have the fancy calculator. That's how you would do it.
And why they need to see?
CDF is because we want less than or equal to. So we want to add up a few R's together. But when we do PDF, we're looking for only one number. So PDF is one number here, where CDF is a collection of numbers.
For this question.
Yeah, you could have. But as I told you guys, like I'm not really a fan of the table. You know, let's look at another question. So a biologist is studying a new hybrid tomato. It is known that the seeds of this hybrid tomato have probability 0.7 of germinating, right? The biologist plants 6 seeds, right? What is the probability that exactly 4 seeds will germinate? So I'm literally asking you in this question, what is the probability of 4, right? What is the probability of 4? And you already know, right? We're gonna do, you can look it up in the table if you want, right? Your N, your N is 6, your probability of success is 0.7, and your R is 4, right? If you're gonna do it in the calculator, what are you looking for, right? So we have binomial, PDF, right? And then my trials, which is the same thing as my N, is equal to 6. My probability of success is going to be 0.7. That's the same thing as my P, by the way. And my X, which is the same thing as R, is going to be what? 4. Now, what does the calculator tell you the answer is? 0.324135. Perfect. Okay. And you got the same answer? Beautiful. All right. So that's how we do that. Let's take it up a notch. So we wish to find the probability of 4, the probability of exactly 4 successes. In table 2 of the appendix, find the section with n equals 6. Excerpt is given in table 610. Then find the entry in the column headed by probability is equal to 0.7, and the row headed by R is equal to 4. The entry is 0.324. Boom. All right. So we about to take this up a notch. So what is the probability that at least 4 seeds will germinate? Oh, that's a little bit different now. What's the probability that at least 4 seeds will germinate, right? So essentially, what am I looking for? I want to know what's the probability of R greater than or equal to 4. Greater than or equal to 4. All right. So since the events are mutually exclusive, the probability of R greater than or equal to 4 is going to be the probability of 4, 5, and 6, of course. Right. And then go ahead, do that one real quick. 4, 5, 6. What answer you get? So let me highlight it for you real quick.
4, 5, 6.
Mm-hmm. Remember that your probability of success is 0.7, your N is 6, and I want the probability of 4 plus 5 plus 6 because they want to know what's the probability of R greater than or equal to 4. So what answer did we get? 7.5, do you agree? Did you get that too? Anybody else? Remember, your n is 6, your probability says 0.7. Just go down, add up where 4, 5, and 6 would be, which is like the bottom three, and then that's it. What you got? I see you looking at the table.
All right, I'm stuck.
You're stuck. Where are you stuck at? This is a new problem, right? So my n is 6. My probability says 0.7. And I want the probability to correspond on the 6 line. No, it's a good question. Oh, yeah.
I found the calculator, my phone is on my phone app. So I'm gonna find the set.
So you got the same answer? No? You have the same answer? So let's look. So we already know the value of 4. We need to find the value of 5 and 6. So use the same part of the table, right? And we find the entries in the rows headed by R is equal to 5 and then R is equal to 6, right? So the probability of 5 is going to be 0.303 and the probability of 6 is going to be 0.118. We're adding them all up together and we get 0.745, right? Awesome. All right, so on the calculator, let's talk about this. .74. All right. I just want to write down real quick and N is 6, P is 0.7. And I want the probability of R greater than or equal to 4. All right. So now, that's good. I want to verify that number. Okay. So now, right, I want to do this in the calculator, right? Remember that the calculator cannot do greater than. So what can the calculator do? The calculator can do less than or equal to. So I have to do the complement of this. So this is going to be 1 minus the probability of R less than or equal to what number? What is it? I want the probability. What I want is the probability of R greater than or equal to 4. So I want 4, 5, 6. But I can't get that in the calculator. 3, 2, 1, 0. So 3. That's what I wanted to hear. All right. So that's what you're going to do in the calculator. All right. So let's elaborate. This is going to be what? This is going to be 1 minus the binomial CDF. And what's the binomial CDF? My trials is going to be N, which is 6. Yeah, at the top, I got it. And then the probability of success which is your P, is 0.7, right? And then your x, in this case, which is the same thing as your r, is going to be equal to 3. But we got something new that we're going to do, something different, right? So watch what we're going to do right here. After you get this answer, right, I want you to store the answer as a variable, right? I want you to store the answer as a variable. So real quick, give me the answer real quick that y'all got. Or get to the answer page. All right, so 0.2569. So you guys could write that out, but let me show you guys how to store it as a variable, right? 25569. Apologize. Okay. So now let me show you guys how to store it as a variable. Okay. Yes, you're gonna go where it says store, and then you're gonna go across, and I want you to pick a variable, right? Go across in the calculator, you're gonna pick a variable. I personally like y, so I'm gonna choose y. All right. So now, after you click on y, you're gonna click enter, right? So y and then enter, for example. After that, you're gonna go down to where it says quit, and then you're gonna click enter. So now you should be back on the main page, right? Are you back on the main page? Awesome. So on the main page, this is what I want you to click. On the main page, I want you to do 1 and then minus, right? Just to recap real quick. This is the minus sign right here, right? 1 minus, and then you see this button right here? This is your variable button. See that? Hit that button until you get back to y. So on the calculator, it should say 1 minus y. And then you should give me the answer from there. Awesome. That's what we got up here, right? Well, we got 0.745. It's okay if it's off by like 1. That can happen. Yeah, that can happen. But this is how you do greater than in the calculator, right? We have to do the complement of it, which is the opposite, the other side, right? You just do 1 minus the answer that you get in the calculator. Questions on this? Make sense? If you're not comfortable with doing this, use a table. Table give you the right answer too. All right. I personally like calculators better, so that's my preference. In terms of showing work, right? Everything that you see here, this is your work. The R greater than or equal to 4 equals 1 minus probability of R less than or equal to 3, then 1 minus the binomial, boom. And you give me the answer at the bottom, that's full credit right there. That's work. All right. That's all I need. Go ahead. If you got the answer without doing it, that's fine. Yeah, that's fine. So, but if you do this in the table though, right? I want this. I want this to work, right? I want probability 4 plus 5 plus 6, and that, and give me that. I'm cool with that. Yeah. All right, all right, all right. Let's keep moving. Real quick. Just want to give y'all the meaning behind this. So what does a binomial probability distribution tell us? When a binomial probability distribution is used, we know the sample space of events can consist of a fixed number n of binomial trials. This means the trials are independent and performed under the same conditions. So there are only two outcomes for each trial: success and failure. The probability of success on each trial is the same and is designated as P. The probability of failure on each trial is designated as Q, and Q is equal to 1 minus P. The binomial probability distribution gives the values of the probability of R, the probability of R successes out of n trials for each R between and including 0 and n. The calculation of the probability of R depends on the probability of depends on the probability P of success on each trial, the value of R, and the value of N. So long story short, as long as we have an N, a P, and an R, it's a binomial distribution question. And we're going through this scenario. You're either using the table or using the calculator. Right? If they say, what's the probability of R equals binomial PDF? You're just going to give me one answer there. If they ask you what's the probability of R less than or equal to something, you're going to use a CDF. If they ask you what's the probability of R greater than something, right? You're going to do the CDF. You're going to save the variable, and then you're going to do 1 minus that variable, and then that's your answer. All right? That's that. Almost there, almost there. I got one more thing to talk about, then we could tap out at that point. All right. So next thing I want to talk about is the mean and the standard deviation of a binomial distribution. All right. So two other features that help describe the graph of any distribution are the balance points of the distribution and the spread of the distribution about the balance point. The balance point is the mean mu of the distribution, and the measure of the spread that is most commonly used is the standard deviation sigma, right? The mean mu is the expected value of the number of successes, okay? For the binomial distribution, we can use two special formulas to compute the mean mu and the standard deviation sigma, right? These are easier to use than the general formula, right, before, all right? General formula is not on your final, that's why I didn't talk about it. But real quick, let me give these to you, and then we could call it a day after one example. So this is the procedure, right? How to compute the mean and the standard deviation for a binomial distribution. The mean mu, also known as the expected value, is equal to n times p, right? And it is the expected number of successes for the random variable r. The standard deviation sigma is equal to the square root of n times p times q, and it is the standard deviation for the random variable r, where r is a random variable representing the number of successes in a binomial distribution. N is the number of trials. P is the probability of success on a single trial. And Q is the probability of failure on a single trial. All right? It might sound like a lot, but it's right here. Right? Chapter 6, right there at the bottom where it says mean. And it says standard deviation. Same formula. It's right there. All right, right above in that same section, you got all the definitions right here. That's at the bottom, right? R is the number of successes, right? P is the probability of success. Q is 1 minus P, which means that it's the probability of failure, right? So everything is laid out. Give y'all an example real quick. So let's say I want to compute the mean and the standard deviation. So let's compute the mean and the standard deviation for a distribution of example 6 that describes the probability of lone diners leaving tips at the Green Spot restaurant. So in example 6, n is equal to 6, our probability of success is 0.7, and our probability of failure is 0.3. For the binomial distribution, the mean or the expected value is going to be n times p. So 6 times 0.7, which gives you 4.2 done. That's it. The balance point of the distribution is at mu is equal to 4.2. The standard deviation is given by sigma is equal to the square root of n times p times q, which is equal to the square root of 6 times 0.7 times 0.3. Little calculator, whatever, you get 1.12. That's it. Questions on this?
So you get Q by,
Doing 1 minus p. Yeah. And it's on your formula sheet, so you don't got to memorize it. All right, chapter 6. This is a part of a question that on your final. All right. Real quick. We'll see if I have anything else to talk about. I think that's about it. Yeah, so when you have a binomial distribution, you're going to identify NPR. They're going to ask you what's the probability of R equal to something, or what's the probability of R less than something, what's the probability of R greater than something. You're going to do that, use a chart calculator. And then they're going to ask you what is the expected value. So that's going to be mu is equal to n times p, right? Then they're going to ask you what is the standard deviation. That sigma is equal to the square root of n times p times q. That's it. That's the whole question. All right. So I guess we can call it at that. Still working on the homework thing. I'll get back to y'all soon on that. Oh, forgot to do attendance. My fault, y'all. Get that from y'all. Just give me 1 second, y'all, before y'all leave. Just trying to get attendance real quick. All right, everybody just sign this real quick for me. I just want your name, your MPhil ID, professor name. Appreciate that, y'all. And as usual, I will email you guys. I can't tell y'all when, but I promise you'll get an email eventually. Is it okay if I stop the recording? Everybody good? Awesome. All right, to those watching the recording, have a good night. See y'all tomorrow, 10 a.m. All right. CPH 309. Yes. All right.